Hey everyone, in this video we are going to create a lot of tables. We are going to create 5 tables for the database, for the data set, the data point, the process parameters, and definitions. So 30 tables today. How we're going to do that is we're going to script as the system table, do some find and replace, save the data. I'll go over a little bit about scripting options, and then we'll get set up to actually start building the information schema, because that's kind of what we're going to be focused on for a little bit, is building the structure so we can manage objects in our system and we can make relationships, things that SQL can't handle effectively by itself. We're taking that over because we know what's best for the data management system. So I'll see you after the title. All right, so the first thing I want to do is go ahead and open up the SSMS options and go down to SQL Server Object Explorer and scripting. And I just want to make sure that our options match, or when we generate scripts, you won't see things that I do. So a couple of these items like identity property, foreign key references, defaults and rules, constraints, foreign keys, like make sure pause this video and make sure everything is all matched up. So next thing is we're going to right click and generate scripts. Right now we can just select all tables because these are the only ones that we have, and just script as create basically, which is the default option. So we're going to replace ref system with ref database, and I chose ref system because if we just replace system, it's going to mess with db system main. And I'm going to add another column because databases are a part of a system. And I'm going to give this system ID the UDT foreign key parent that we declared way back in 03. And the rest of it should be good. However, I want to find where I declare defaults and add the system ID in its respective location. And I'm just going to copy paste the new default constraint. Name it the same, null default, and then I'll scroll all the way down and find the foreign key references. That one will work. So we'll just copy this block, paste it, and I believe we can just change database type with system. So this should be our database table, equipped with foreign key references and everything. So let's just run this. And for the rest of the tables, we just need to follow a pattern. So we will replace ref database with ref dataset, and then ref system with ref database, because a data set is like a table or file. It belongs to a database. Database is system. Same kind of pattern that we've been using for realm, class, family, type. So I just save that table and we'll do it again. Ref data set with ref data point, and then ref database with ref data set. And again, it's important that we use ref because we do have specific data set number as a column, and we don't want to overwrite that. So next up, ref data point with ref process, and ref data set, we're going to move up one because processes are functions, procedures, and they belong to a database. And then finally, process with process parameters, and this is a very important order because process parameters contains the word process. If we replace process, we're going to get a bunch of things that will not compile correctly or be what we want. And then ref database with ref process. So that should be good for most of our tables, and I just want to make sure that the foreign keys got hooked up, that the relationships are there. So I'm going to take a moment to check my work. So we have the data set, And let's see, the data point links to the data set. And process should link to database. All right. Process parameter to process. So now I'm just going to hold Control Z so we go back to the system. So I undid everything that I just did, and I just need to replace system with definition because the definitions don't have a parent. And then I can run that, and that should be our last table, our definition table. Sometimes we will need a parent foreign key for a defined relationship. Other times we will be using a single relationship table for changing relationships. So that is our 30 tables in only a few minutes. I'm just making sure everything is all set up. Because I have some extra time, I want to go ahead and create a snippet of a piece of code that I will be using very regularly because this is a pattern-based system. We're going to be calling this realm class family type to get the base ID over and over and over again. So I'm just following the simple pattern that I'll need to follow. You select your ID from the table, the base table, where your subject type ID is in, and then we repeat the process, the pattern that we continually do. The base gets replaced with type. The type gets replaced with family. So here I'm just creating my type ID, and I'll copy, select type ID where family ID in, format it. Now I can start finding replacing. So replace family with class, and then replace type with family. So do it again, copy, paste, format. I'll replace class with realm, and then family with class. And then one more time, but we only need the select from where, we don't need the and in, and this will just be replacing class with realm. And that will give us the chain. This is kind of how our functions will look when we dynamically generate our functions for our system. So in here, I'm just going to copy the code I've created. Those $ represent parameters. And I'm just going to create a new snippet, get RCFT base ID, paste my code in here, and save it. And what these $ allow me to do is I can execute the snippet and then just type, ref system, and it fills out the rest of it. And that can kind of work backwards. One system, two rule, and I'll just add the key name here and execute. So this is the class family type pattern that we're going to be using in so many of our videos. It's a core piece of the system. So that's about it for this video. Thank you very much for watching. Hope you enjoyed it. Remember, like this video to recommend it, subscribe to support me, and I'll see you in the next one. Have a good one.